Right, hello. This is going to be about searching. So we're going to look at a binary search and a linear search. Now, a linear search is really straightforward. So let's say I'm searching for 73 here. Start at the beginning, no, no, no. Just go one next each time. Found it, took 5 goes. Okay. Now, the advantages of that is it's very simple. All right, it's easy to code. The other thing is that the list does not need to be sorted. All right. Now, the other thing we look at is a binary search. Now, the thing about a binary search is it does require a sorted list, but it is much quicker. So let's have a look. Try and make this a bit bigger, this code, because you can barely see it. Right. Okay. So what do we do then? Well, it's essentially like a phone book, right? So it's in order. So you're going to basically halve each time you search and you fail to find it, you effectively halve the actual search list each time. Right, so let's do. So I'm going to search for 73 again. So to search for is 73. All right, that's what I'm looking for. Now, obviously, I can't. Obviously, I can see it there, but I mean, you wouldn't be able to do that. Right, so number to search for, as I said, is 73. Found is false, count is 0. I'm making a copy of the original array. Then I sort it using my bubble sort algorithm. So again, you can just use that one you've already created because you just send in an array and it will sort it. Super job. Then we now have this. So we have mid is 0. Lower is 0. So lower is our lower limit of our list. So lower is going to go to 0. And upper, we'll ignore mid in a minute, upper is the length of the binary search array minus 1. So it's currently 7, so take 1 off it is 6. So that's going to be at position 6. So now we have our upper and lower bounds of our search. Now it says mid is 0, we'll just keep it there for now. It's not going to stay 0 for long. Right, I have a do while loop here, which won't please you Python fans, but yeah, I'm using a do while loop. Now I've got my count there. So count is recording how many times it takes to find something. So this is the crucial line here. Mid is equal to upper plus lower divided by 2. So mid is 0, sorry, lower is 0, upper is 6. So 0 plus 6 divided by 2. We're just doing integer division, so if there's any points, it's just going to go for the low one. Right, so there's our midpoint. Now, every search is taken from the midpoint. Now, some of you are going to say, well, why don't we use upper and lower? Well, it's no longer a binary search if we do that. Right, so we say if number to search for is the array at midpoint, which is 44, it's not. Right, so there we go. Now we say else if number to search for, which is 73, is it greater than the number that we found at mid, which is 44? The answer is yes. So what we can now do is we can say we move lower to mid plus 1. Right, so lower now goes there. Right, so essentially we're saying we know what we're looking for is somewhere between lower than upper. We can exclude the entirety of that list from 0 to 3, including 3. All right, because obviously if it was at mid, we would have found it. Right, so while found is equal to false, well, found is false, so we're going to keep going. So back up, we add 1 to count, so it's now 2. We work out the new mid, so it's upper plus lower divided by 2. So 4 and 6 is 10, divide that by 2 is 5, so our midpoint is going to go there. Right, if number to search for equals bin search array mid, oh yes, it does. All right, so we found is true. All right, so we quit out of the loop. It took us 2 goes. So it took us 2 goes to find it instead of 6 otherwise. All right, so that's the way you're going to code it. All right. Now, there is another example of a binary search there, which I'm not going to go over now. Now, in terms of the program, what does that involve? Well, let's. You'll notice that you don't actually have any options for binary search and linear search. So you're going to have to add these in here and in the case statement and add the functions itself. Now, in terms of how it's going to look like when you've finished, it will look like this. I should have loaded this up earlier. It's fine. Come on. Right, okay, so let's run that. And you'll see this one will have all the options eventually. Now my function will actually sort the array. So how many numbers? We'll just do 10. Right, so there's my array there. Now let's do a binary search. So 6. So I'm not going to. So it's displayed it again, so I can see what number. So let's go for 797. 3 goes. All right. Now if I did a linear search on that, 797. Let's see, it took 9 goes, so it's better. But it did have to search it. It did sort the list first. Okay. There we go. So that's what you need to be doing now. After you've done the sorting, the bubble sort, the efficient bubble sort, the linear and the binary. Now a good description of the merge sort can be found at this link that I gave you. Oh God, I can't find anything. Where is it? Where is it? There. There. All right. So it's that one there. So there we go. So basically, your tasks are to do the bubble sort, the efficient bubble sort, and then code from pseudocode. You can do the linear search without looking at my pseudocode, which maybe seems a little bit over the top, but it's fine. But it does need to output. So there's the code for the linear search, the pseudocode. There's the code that I was using just now. There we go. So that's your task now. As I said before, I will provide you with a place to put your code on OneNote so I can see it. Okay, that is searching. Thank you.